The next expansion involves two binomial expressions. And a binomial expression is an expression where we have two, that's what the bi means, two numbers or two terms. Okay, so in each set of brackets we have two terms, 2x and a minus 3, a 4y squared and a 3x to the half. So two terms, each of these brackets is a binomial. Now, to expand a binomial, it's going to be exactly the same as when we had binomials with surds in them. We're going to use the FOIL method. First, outside, inside, last. First terms, outside terms, inside terms, and the last terms. If you want a little bit more detail on where FOIL comes from and why it works, have a look at my videos from week number 1 with surds. But let's just dive straight into this one. Process is going to be very similar. The only difference will be we'll have a little bit of index laws to apply to simplify the final result. So, first step, 2x times 4y squared is 8xy squared. Outside terms, 2x times 3x to the half. Now that's a little bit complicated, so I'm just going to leave it unsimplified, just for the moment. Inside terms, negative 3 times 4y squared. So, negative 3 times 4y squared. Finally, negative 3 times 3x to the half. And there's my 4 terms. Now I did the first one very quickly. I went straight to 8xy squared. If you're not confident about that, you could write them out in full like I have for these ones, and then simplify it on the next step. But if you can go straight to that as well with all of these, that's fine as well. Alright, let's have a look here. Now, multiplication tells me I can change the order, so I can do 2 times 3 first. 2 times 3 is 6. And I'm going to have an x times an x to the half. Now, what does my index law number 1 say? When I've got two things that are the same base multiplied together, but this is a 1 even though I don't write it there, the law tells me that I can add these two powers together. So I get x to the power of 1 plus a half, or x to the power of 1 and a half. Now, I don't really like writing surds like this because it can be a bit ambiguous what this means, whether I mean 1 times a half or 1 and a half. So the best way to do this is to write it as an improper fraction. 1 and a half is the same as 3 on 2. So this term, 2 times 3 was 6, x times x to the half, I've just worked out is x to the 3 on 2. Similarly, this next term, 3 times 4 is 12, and I've just got a y squared. And the last term, negative 3 times 3 is negative 9, and it's going to be an x to the half. Now, if all the question said was expand, this would be the correct answer. Okay, I can't simplify any of this any further. There's no like terms. Everything has different pronumerals. If, however, the question said something like expand, leaving your answer without fractional indices, so if it asks for it without fractional indices, I need to get rid of these. And to do that, I could use my index laws. So in this case, I can rewrite this here, the x to the 3 on 2, without the fractional index. And remember, the number on the top tells us the power we're raising x to. The number on the bottom tells us what root we're dealing with. So it's a 2 on the bottom, so that's the square root. Similarly, this one here, x to the half, well, that's just the square root of x.